Section 7.6, example 7, solving a dependent system of linear equations using matrices. So the following system of linear equations using matrices. Okay. Let's just throw this into a matrix and see what the numbers are telling us. So again, all we have to do is grab the coefficients. First column is our x column, second column is our y column, third column is our z column, and fourth column is our constants column. So -1, -2, 1, and -1. And next one, we have 2 for x. Do we have any y's? Yes. 3. Do we have any z's? No. So for z's, we're going to put a 0. And constant is 2. Here, x's, we don't have any x's. Y's, we have 1 y. -2 z's, and 0 for the constants. All right, so our goal is to get 1 in the diagonals. So top left-hand corner, we have -1. So let's turn that into a +1. We could easily do that by just multiplying it by -1. So -1 times row 1 for the new row 1. And here we're just multiplying everything by -1. So switching the sign. So this is now +1, +2, -1, and +1. We're not manipulating the other rows, so we could just rewrite these. All right, looks good because now we have a 0 here, so we only have to work with this one. So we just have to turn this one into a 0 as well. Right now, this is our working row because we have a 1 here. We're trying to turn everything else in the column into a 0. So opposite of +2 is going to be -2. So we're multiplying our working row, row 1 by -2, and adding it to the row we want to manipulate. So manipulating row 2 for the new row 2. And we don't have to do anything to that third column. I'm sorry, to the third row because it already has a 0 where we need it. We're not manipulating row 1, so let's copy that one down. We're not manipulating row 3, so we could copy that one down as well. And let's get our solution for row 2. All right, so row 1 times -2. So we have 1 times -2 is -2. -2 plus 2 is 0. And now 2. 2 times -2 is a -4. -4 plus 3 is a -1. Then row 1, -1 times -2 is a +2. Oh, +2. 0 plus 2 is 2. And lastly, 1 times -2 is -2. 2 plus -2 is a positive or a 0. All right, looks good. So now that we have this, we have 1s where we need it. So 1, 0, 0, 0, 1, 0, 0, 0, 1. All right, so we have this one done. If we switch these two, we end up with a 1 where we need it. So let's just do that. We could technically do either or. We could multiply this by -1 because we have a -1 here. We could turn this easily to a +1. You know what? Let's do that. So let's do -1. Actually, no, let's switch it. I feel like it'll be a little bit easier. Let's just switch. All right, so row 1 is not being manipulated whatsoever. And here we're switching row 1 and row 2. So we're switching row 3 and row 4. So 0, 1, -2, 0. and 0, -1, +2, 0. All right, let's get, so we have column 1 done. We have a 1 where we need it for column 2. So let's turn these two into zeros. Let's start with this one up here. So this is now our working row. So row 2 are working rows. So opposite, let's turn this into a 0. Turning this into a 0, opposite of +2 is going to be -2. So -2 times row 2, which is our working row, plus row 1, the row we're trying to manipulate for the new row 1. Similarly, down here, opposite of -1 is +1, so we're just adding those two rows together. So row 2 plus row 3, I was going to write row 1. Row 3, and this is going to be for the new row 3. All right, so row 2 is not being manipulated whatsoever. Okay, we have that. Let's start with row 1. So -2 times row 2. So 0 times -2 is going to be -2. 1, oh. Yeah, 0 times -2 is 0, not -2. 1 plus 0 is still 1. And row 2, so 1 times -2 is -2. There we go. -2 plus 2 is 0. And here we have -2. -2 times -2 is a +4. +4 plus 1 is 3, or -1 is 3. And 0 times -2 is 0. 0 plus 1 is 1. And now here for row 3, we're just adding straight down. So we have 0 plus 0 is 0. We have 1 minus 1 is 0. 2, -2 plus 2 is 0. 0 and 0 is 0. So this last equation just showed that we have 0 equal to 0. So that tells us that we have infinitely many solutions. Infinitely many solutions. All right, so what does this mean? We're going to rewrite everything in terms of x. Yeah, let's make it in terms of x. So let's see what that solution is first. All right, to find the solutions to all of this, let's get these equations. So the first equation is x plus 3y equals 1. The next one is y minus 2z is equal to 0. Oh, that's not y, that's z. Makes way more sense this way. So x plus 3z equals 1. Let's find out, let's get these in terms of x. Let's move these equations up here so we have a little bit more room to work with. So starting with this first equation, x plus 3z is equal to 1. Remember, we want everything to be in terms of x. So let's solve for z here. So we have 3z is equal to -x plus 1. We have z is equal to -1 over 3x plus 1 over 3. So that's z so far. X is going to be x. This is what z is. Let's figure out what y is. So we have y minus 2z is equal to 0. Here we have y is equal to 2z. That's not in terms of x. So what we're going to do is plug in z in here to get that solution. Because z is in terms of x. So in this case, y is equal to 2z. We're plugging in what we got for z. And we have y is equal to a negative 2 over 3x plus 2 over 3. That's our z. X is just going to be x. So our solution here is x is x, y is at negative 2 over 3x plus 2 over 3. And z is that right there, a negative 1 over 3x plus 1 over 3. And there we go. That's our solution right here. So if you have any questions whatsoever, please feel free to ask. Otherwise, bye.